In this lesson, we're going to talk about the basics of UI. So, what exactly do UI and GUI stand for, and what's the difference? UI stands for user interface, and GUI, pronounced GUI, stands for the graphical user interface. To interface means to interact with. So, the user interface is the set of devices that lets the player interact with the game. The mouse, keyboard, game controller, touchscreen, and so on are all part of the user interface. Graphical user interface is the subset of user interfaces that is represented by graphics. So on-screen buttons, drop-down menus, and icons are all part of a game's GUI. This class will focus primarily on the GUI design, but it will design some non-graphical aspects of user interfaces, like controls, accessing data from the mouse, screen tap, keyboard, or a controller. As GUI is a subset of UI, many people, myself included, tend to just refer to GUI as UI. In fact, Unity also refers to all GUI items they provide as a template for a UI. The next part of the lesson, we're going to jump into Unity and take a look at how we can create canvases, panels, how to use the rect tool, and how to mess with the pivot points, as well as set up background images and pop-up menus. All right, so here we are in Unity. Let's start by creating a UI canvas. You right-click in the hierarchy, go down to UI, and create a canvas. Now, every UI element you create must be a child of a UI canvas. So by child, what I mean is, let's say we want to add a button. You can go to UI here, and then you can go down to really any of these. For instance, button. And down here in the bottom, you see the button, but you don't see it in your view. If I double click my button, it'll actually take me here. I'm going to hold Alt and the left mouse button here. And just kind of holding Alt and left click, I can rotate, scrolling in and out with my middle wheel, I can zoom. You can adjust the button properties up here where it says Rect Transform to make your button bigger. So let's say we wanted our button twice as big. Now you might be wondering, well, where's the canvas in this canvas here? Well, that's this white box here that represents the canvas. And right now it's 16 by 9 is the aspect ratio. If I go 16 by 10, notice that this changes as well. You can also type in your own custom aspect ratio or select one of these by clicking this plus button here. And that'll add a new one that you could type in. For now, let's just do 16 by 9. Now, back in our side here, in our inspector with our canvas selected, every new canvas comes with essentially 4 components: canvas, canvas scaler, and this one here, which is canvas raycaster. You could see as I expand those, each one comes with their own set of properties. Now, as mentioned already, when we were playing with the button here, that you have this Rect Transform property, and this allows you to adjust the scale and other elements. Now, if we scroll down a little bit from our Rect Transform, we look at the canvas here. The canvas component allows you to select the canvas render mode. So if you see here, it says render mode, and you have these options: screen space overlay, screen space camera, and world space. We'll be using these when we build our different game UIs. But what these different render modes determine is where in the scene the UI elements will be drawn. It is important to mention below these a couple of what these 3 options essentially mean. Now, Pixel Perfect is essentially appears. This option can make the UI element appear sharper and less blurry. So this can also cause performance issues, so only use it if it's absolutely necessary. And then we have below that sort order. Now this option only applies when you have multiple canvases in the scene, and you want to which one should be on top of the other, or how they should sort in relation to the camera. So you want to think about this as things, the higher the number, the closer to the items within the canvas will appear to the person viewing the scene. So in other words, higher numbered canvases will appear on top of lower numbered canvases. And then we have this target display here. Now, if you're creating a PC, Mac, Linux standalone game, you can have different cameras displayed on up to 8 different monitors. You can also have different UIs for each monitor, and also where you let the canvas display which one it'll render on. So that's where you want to adjust your camera, your target displays. Then there's the last component here, which is the canvas scaler component, and this determines how the items within the canvas will scale. It also determines the pixel density of the item within the UI canvas. So here you could see there's constant pixel size, then we have scale with screen size, and then we have constant physical size. Now, the world component, they used to have a world one depending on how old your version of Unity is. That's been moved into the canvas, or into the canvas section. Now, you might be wondering, well, why do we have this canvas scalar component? Shouldn't it always scale? Well, due to the fact that you can't guarantee the resolution or aspect ratio of your game, for instance, like say you're playing a mobile game, there's like a million different mobile devices. The need for your UI to adjust to various resolutions and scaling is very important. That's why this canvas scalar component exists. Now, by default, you can see it's set to constant pixel size. And when a canvas has the UI scale mode set to constant pixel size, every item in the UI will maintain its original pixel size regardless of the size of the screen. You don't look at this default setting, so by default, UI does not scale. You must turn the setting on for it to scale with altering screen modes. Now, what most people, believe it or not, are actually interested in is this graphics raycaster. The graphics raycaster allows you to check to see whether objects on the canvas have been hit by user input using the event system. So, for instance, when we're looking at the world space canvas render mode, which is when your canvas is in the world, and a user touches the screen, a ray is cast forward from the point on the screen. So you can think about it as sort of the camera in which the player touches. So the graphics raycaster checks these rays to see if it hits something on the canvas. All right, so a couple things that I like to use, for instance, a panel. So I'm going to right click here, go to UI, and then have a panel here. And I can make this button a child of my panel. Now, what's nice about panels is if you look at my button here, notice that it stays stationary in the center here. Panels are very useful when you're trying to ensure that items scale and are appropriately relative to each other. Items that are contained within the same panel will scale relative to the panel itself. So I think overall, that's a pretty good basic overview of the UI because we're going to be doing a lot of different types of programming and building a lot of different types of games using these UI different elements. I'm going to go ahead and end this lesson here. And then in the next one, we'll start to look at the event system and how you can program it for UI.